Yeah, the naming of the triangle is as the following. Suppose the vertices are named using capital letters A, B, C, then the sides opposite of those vertices is named after the vertex. Okay, so for example, if this is vertex A, then the side opposite to that vertex A is named lowercase a. Okay, and then the side opposite of vertex B is named B. The side opposite of vertex C is named C. Okay, that's the naming. Now, our textbook, however, use the following further extra notation. Our textbook actually use these extra things. The angle, they name this angle A as angle alpha, angle B as angle beta, and angle C is angle gamma. Now, that's how our textbook actually name it. Now, law of sine says the following. The ratio of the sine of an angle to the length of the side opposite to it is constant in a triangle. So sine A over side A is equal to sine of angle B over length of side B equals to sine angle C over side C. That's what law of sine says. Now, before I prove this, I would like to prove something that we will prove anyway in 7.2. That's something we can prove actually a lot earlier. That's something we can prove a lot earlier. What is that? Before I prove that, I will do another thing called area of a triangle given two sides and included angle. So after I prove this, after I show you the formula, you need to memorize this formula though, okay? You need to memorize this formula. After I show you the formula, get you the formula, then you will see that law of sine is the consequence of this. So let's say I have a random triangle. And in this random triangle, I know vertex A. And let's call this B. So this is side B. If this is C, then this is side C. Okay. Now it is known that we know that area of this triangle is equal to 1/2 times base times height. Okay. If we use B as our base, suppose this is our base, then the height will be the one perpendicular to that base B. We call this height also the altitude. Okay, now the thing is, what is the height of from this base B? Notice that sine A is equal to that height over C. Is that right? In that triangle. Maybe I redraw the triangle here. So if this is A, this is a right triangle, this is the height, this is C. Okay, so we see that the height can be written as side C sine A. Now that's what I will use here. Okay, so now we have the area of a triangle is equal to 1/2 times the base, in this case B, times the height, in this case C sine A. Okay, so notice that BC is the length of the product of uh, the length of two sides, and angle A is the included angle, the angle in between those two sides. Okay, now of course I can play with the variables. Instead of 1/2 BC sine A, I can make it 1/2 AC sine B, or 1/2 AB sine C. Now it's the same triangle, right? So all these three should be the same. Okay, now the thing is, I need you to memorize this formula, therefore. Okay, not only this one, which I do expect you to already memorize, I still memorize, then I expect you to memorize this also. Okay, now you don't need to memorize all three variations of this formula though. You just need to know that the area of a triangle is 1/2 the product of two sides times the sine of the included angle. Okay, now we will have that kind of question, or we may be able to answer this kind of question in the 7.1, but that's actually something our textbook proves in 7.2. Now, I will go on, then going back to, now we will prove of law of sine, the law of sines. Is the consequence of the areas of the triangle we had earlier. Of course, there's another way to prove that, right? Okay, but the proof will be actually as the following. We know that the area of this triangle is 1/2 BC sine A, but in the same triangle, the area has to be the same. That's equals to 1/2 AC sine B equals to 1/2 AB sine C. Give me a second, give me a second. Now, what we will do next is, let me do this first. Let me multiply by 2 for the last three expressions. I multiply this by 2 first. So I get BC sine A equals to AC sine B equals to AB sine C. That's in the same triangle. I go further, I will divide all three expressions by ABC. That will give me sine A over A equals to sine B over B equals to sine C over C. Okay, that's basically the end of the proof. I actually tempted to show the proof using the proof in our textbook. So read your textbook, okay? The way they prove law of sine without showing the proof for the area of a triangle. I think that's something still worth knowing, you know? But instead of going over the one in the book, which I think will take similar amount of time, in the same amount of time, I actually give you two formulas. And besides law of sines, we also have another new formula for the area of a triangle. Okay, now everything after this is just application. Now, but before I do the application, let me define one thing. I'm not sure if you already know this. It's supposed to be known if you learn geometry, but this is the thing. I need to define what we meant by solve a triangle. Now, in a triangle, there are 6 parts. We will have 3 angles and we will have 3 sides. Is that right? Okay, now then, to solve a triangle, is to find the values of all these 6 parts. Okay, now of course, usually 3 of those 6 are given. Okay, now, so suppose, for example, I do number 2. Number 2 in our textbook, page 488. We are given angle A is 52 degrees. I'm sorry, angle B. I'll look at number 1 instead. Angle alpha is unknown, beta is 45 degrees, and angle gamma is 41 degrees. Let me give you the better picture. So let's say this is our triangle. This is vertex A, vertex B, vertex C. Then angle alpha is the angle for vertex A, angle beta is the angle for vertex B, angle gamma is the angle for vertex C. Okay, now and then also given to us the length of side B, which is 170. Now what we need to do is to find the rest of these 6 parts. Okay, now you will see that law of sine is doable if we know one pair. Okay, if you know one pair, in this case I know angle B and side B. You will see that I always write it with me. I always write it in this pattern. The angles on the top and then the sides on the bottom. Okay, now then when I say when do we use law of sine? We use law of sine if we have one pair known. Either this pair or this pair or this pair. Okay, if you have one pair known, then we use law of sine. Otherwise, you will see we supplement that using law of cosine. So things that cannot be done using law of sine will be done by law of cosine. Okay, even though there are more things to say there. Now, then the question in number 2 here is to solve the triangle. Now, the solve the triangle is finding the rest. Okay, now What can we do first here? Actually, we can do two things. I can find angle A and I can find side C, but let me do side C first. What is side C? Then I use law of sines. Sine beta over B equals to sine gamma over C. Write the formula first and then plug in numbers. Sine 25 degrees over 170 equals to sine 41 degrees over C. And cross multiply C sine 25 degrees equals to 170 sine 41 degrees. And then C is equals to 170 sine 41 degrees over sine 45 degrees. Okay? Then use your calculator. But don't forget to check your mode. Your mode has to be in degrees. Okay. Let's do it together. I get my C is 263.90255. So my side C is, this is what I do first, okay, 263.90255. Is it okay? Then from there, we will find angle alpha, which I think is easy to do, right? How to find angle alpha? Yeah, we use this property that the sum of the interior angles of a triangle is 180 degrees. Okay, so alpha plus 25 degrees plus 41 degrees equals to 180 degrees. So alpha equals to that's 66. So 124 degrees. No, 114 degrees. Now then, once you get that 114 degrees, then you find side A. Okay, let me pull a line here. Then you find side A. Find side A, I will apply law of sine again. Sine alpha over A equals to sine beta over B. Okay, can you work on that? Let me give you maybe 2 minutes to work on this. Okay, let's work it out. This is sine 114 degrees over A equals to sine 25 degrees over 170. Of course, you can use sine alpha over C. You can use this too. Now, the problem is your C here is a rounded answer, right? So you already have some rounding error there. If you use that further, you may have a compounded rounding error. So I suggest you to use the numbers. If as much as possible, try to use the number that is given by the question. Okay, that way we avoid rounding error, a compounded rounding error. Or Just in case that your C happens to be wrong, you don't carry that mistake further, right? Okay, that's why I use the pair beta and D. Then A will be equal to 170 sine 140 degrees over sine 25 degrees. Okay, so A will be, let's see, what do I get? 170 sine 114 divided by sine 25 degrees. I get 367.47756. So my third part is side A, 367.47756. Okay, now that's one example of applying law of sine. Before I go on further, especially to a more complicated situation, I would like to go over three important uh, properties from geometry. And let me call that a note. Actually, a notes. Okay, the first one, something we have seen, that in a triangle, the sum of the interior angles is 180 degrees. That's something we know easily. Okay, but a property that's not really being used a lot in geometry, but important here, is the following. In a triangle, the larger the triangle, or the larger the angle, the longer the opposite side. Vice versa. The longer the opposite side, the larger the angle. Okay, now let's see, suppose we can actually see it this way here. Notice that if I name this angle A, vertex B, and vertex C, visually here you can see that angle B is the largest angle among these three angles, right? Now, because angle B is the largest, then side B will be the longest. Okay, if B is the largest angle, then side B is the longest side. Right? Now, consequently, also from this triangle, you can see that angle C is the smallest angle. Therefore, side C is the shortest angle, shortest side. Okay, if C is the smallest angle, then side C is the shortest side. Okay. Now, the third observation that we will need to use very soon is something from trigonometry, okay, which is the following. Now, sine A is, if sine A is positive, Okay, maybe to be more precise, if sine A is positive but less than 1. So if sine A is positive but less than 1, then there are uh, two angles satisfying that. Two angles A satisfying that. That either A is in quadrant 1 or A is in quadrant 2. For little example, suppose I say that sine A equals to 1/2, and either A is 30 degrees, that's in quadrant 1, or A is 150 degrees, which is in quadrant 2. Okay? Now, we will use these three principles here for the rest of our sections, and even next chapter, next section 7.2. Okay, let's do number 4 first. That's something you can do on your own. Number four, angle beta is 50 degrees, 50 seconds. 50 minutes. Now change this into full degree first. So 50 over 60 this is equals to 50.8333 degrees. And angle gamma is 70 degrees, 30 minutes, which is 70.5 degrees. Now, of course, you can easily find angle A. Okay, you can easily find angle A. Here they give us side C, which is 537. I guess what you will do is find side B first. Let's call that your first step, the slightly harder one, right? And you will use law of sine for that. And then the second thing you will do is find angle alpha. The third thing you will do is find side A. Okay, this should take approximately 5 minutes. Let me give you 5 minutes to do this. So my side B, I will use sine beta over side B equals to sine gamma over side C. So sine 50.8333 over B equals to sine 70.5 degrees over 537. Therefore, side B is 537 sine 50.8333 degrees over sine 70.5. Now, before I go on, I would like to do this kind of observation before I compute. Notice that angle 70 degrees something here is larger than 50 degrees something. So we expect this C, 537, is larger than the B. In other words, the side B that we get later on should be less than 537. Okay, should be less than 537. Now then, when I use my calculator, let's confirm that that's what we get. 537 sine of 50.83333 divided by sine 70.5 degrees. I get 441.67648. Okay, that's side B. How about angle alpha? Alpha plus beta plus gamma is 180 degrees. So alpha plus, what is my beta? 50.83333 degrees plus 70.5 degrees equals to 180 degrees. Let me add those first. So this is alpha plus 121, 121.3333 degrees equals to 180 degrees. So alpha is 58.66667 degrees. Now this 58.66667 degrees, therefore, so this is 58. Let me just put columns here. This is 58.3333 degrees. Now, therefore, later on you will see the side here, A, notice the angle alpha is larger than beta, but less than gamma, right? So our side A here must be, less than 537, but more than whatever we have in OP, which is 441. That's 441.67648. Okay, so this side A here must be greater than 441 something, but less than 537. Okay, now I think right now we don't really need that because we can just go on with the computation, right? We can just go on with the computation and put this down. Do the partition so that I can work on my A here. Side A is sine alpha over A equals to sine gamma over C. Sine 58.3333 degrees over A equals to sine 70.5 degrees over 537. So side A is 537 sine 58.3333 degrees over sine 70.5 degrees. Seven sine 58.3333 divided by sine 70.5. I get 484.86051. Let me see, did I get a note from somebody? 50 point. Am I okay now? Oh, okay, good, thank you. So, yes, it's a sine alpha, right? So that I use alpha there. I still make a mistake. Thank you. It's actually, thank you. If you don't correct me there. Yeah, somebody sent me a notice, he or she said it should be 50.3333, 50.83333, but no, it should be, I make a mistake here. Should be 66667. 66667. What did I write up there? So this one is wrong. This one is wrong. I wrote it, I copied it incorrectly. This should be 58.33. I'm sorry. I tried to correct that into something even worse. This is 66667 degrees. My bad, my bad, my bad. So my last answer here is not correct, but I think it's just a bit off. 537 sine 58.66667 divided by sine 70.5. So 486.59223. Four 59223. 486 59223. Okay, now this is the foundation for law of sine. Notice that what we have done so far, is when we know two angles and one side. Okay, when we know two angles and one side. Actually, once you know two angles, you know the third angle. Once you know two angles, you know the third angle. So basically, from geometry point of view, we are able to tackle the same, using the same situation, the same law of sine, if we know angle, side angle instead. Okay? Thomas, what's the difference between AAS and ASA? Now, the first one here is when we know two adjacent angles, let's say these two adjacent angles, and the side is not in between. So this is angle, side. Okay, but what I'm trying to say earlier is, like, if we know two angles, we actually know, consequently, we also know the third side, the third angle. Okay, now while angle, side angles refers to a situation where you know two angles, and in the side is in between. The side is in between. Now, what I said earlier is, if we know two angles, then you know the third angle. Now, so suppose I know these two angles here, then I will be able to find this angle by using the sum of interior angle is 180 degrees. Okay? Now, the more difficult situation is when we have two sides. If we have two sides and one angle. Let's say, for example, we do number 16. Let's say, for example, we do number 16. Number 16, we have angle gamma. So alpha is unknown, beta is unknown, angle gamma is known to be 73.01 degrees. And then side A is 17.31. And side C to be 20.24. Now, of course, what we can do here first is to find angle alpha. That's our first step. Okay, that's our first step. After we get angle alpha, we will find angle beta and then side B. Okay. Now, one observation here is notice that side C is greater than side A, longer than side A. So angle gamma, consequently, which is 73 degrees, must be greater than angle alpha. Another way to say it then, angle alpha is less than 73 degrees. This alpha here will be less than 73.01 degrees. Okay, how do we know that, Thomas? Because side A is shorter than side C. Okay, now that will help us later on when we try to answer what is angle alpha. Okay. Let's start. We'll first find angle alpha. Sine alpha over 17 point, let me slow down. Over A equals to sine gamma over side C. Sine alpha over 17.31 equals to sine 73.01 degrees over 20.4. Okay, you can start working on this on your own actually, but I will just do it too. So sine alpha is 17.31 sine 73.01 degrees over 20.24. So my sine alpha will be I get 0.81791. Notice that I always round it to 5 decimal places. Now then, sine alpha equals to that, then alpha will be the sine inverse of this, right? Now we learned sine inverse earlier. Sine inverse of a positive number will give us answer in quadrant 1. That is 54.87622 degrees. Now that's the angle in quadrant 1. But we also have an angle in quadrant 2 that gives us the same value, which is 180 minus whatever angles you have in quadrant 1. That will give us 125.12378 degrees. Okay, so when you find the angle, sine of an angle, it should give you 2 solutions. However, then we will cancel the second solution here. This is not applied because we know that alpha has to be less than 73.01 degrees. Okay, and the reason is because side A is less than side C. Okay, remember notes number 2. Note number 2. The longer the side, the longer the opposite angle. The larger the opposite angle. The larger the angle, the longer the opposite sides. Okay, so we use that knowledge that we learned from geometry to cancel one of the possible solutions. Okay, so if I go back there, I then get this guy is 54.876 22 degrees. Now then, continue from there, we'll find angle beta, right? But I think you can find angle beta yourself. Angle beta is alpha plus beta plus gamma equals to 180 degrees, right? So it's 54.87622 degrees plus beta plus 73.01 degrees is 180 degrees. Beta plus 127, huh? 127.8862 degrees. So beta will be 52.11378 degrees. And then we find side B, you apply law of sine again. Okay. Now, the routine to find angle beta and angle B was something we have done earlier. So I will not go over that with you again. You can just go on yourself. Now, one warning, however, here I cancel one of the angle. Here I cancel one of the angle because I have a reason to cancel it. Okay. It is possible, however, we get a situation with two angles, that both of these angles are possible. Now, let's say, for example, question number 10. Let's say I use question number 10. Question number 10, alpha equals to 27 degrees and 30 minutes. Let me change it to 30 minutes. So let me change it to degrees right away, 27.5 degrees. That's alpha. And side A is 28.1. Angle beta is unknown, side B is unknown, angle gamma is unknown, but side C is 52.8. Okay, so what I will do first is to find this angle gamma. Now let me ask you to work on that. So angle gamma, we will use sine alpha over A equals to sine gamma over C. That's sine 27.5 degrees over 28.1 equals to sine gamma over 52.8. Now we know because the side A here is less than side C, so angle alpha will be smaller than angle gamma. That's all we know actually. Okay, that's all we know. Of course, the sum has to be less than 180 degrees also, right? But you will see that there are two possible gamma in this case when you do the computation. Okay, let me ask you to do that. I will do this too, but I want you to do it independently, then look at my solution. Now, as you can see here, that both of these angles actually okay. Notice that both of these angles both are okay because gamma 1 and gamma 2 are both greater than 27.5 degrees. Okay, and gamma 1 plus alpha is less than 180 degrees. Gamma 2 plus alpha also less than 180 degrees. So you see, both of them satisfy the rules the notes that we have earlier. We cannot cancel any one of them. Okay, so let me put it up here. So we have gamma 1 to be 60.18407 degrees, but we also have gamma 2, which is 119.81593 degrees. Now, because I have two gammas, consequently later on, I will have two betas. Beta 1 correspond to gamma 1, beta 2 correspond to gamma 2. Okay, now let's work it out. So if I need to find angle beta, then alpha plus beta plus gamma equals to 180 degrees. For beta 1, 27.5 degrees plus beta 1 plus gamma 1 equals to 180 degrees. So beta 1 will be 92.3159. For beta 2, you can compute it yourself. Now then, consequently, later on, you will have B1 and also B2. Okay? You will also have B1 and B2. So let me ask you to compute this beta 2. Let me ask you to compute this beta 2. Okay, and then together with that, compute B1 and B2. Together with your break, we come back at 11 o'clock. So that should, no, maybe, yeah, 11 o'clock should be good enough. Okay, let me continue. I already work on beta 1. Oh, no, I did beta 1. Beta 2. And then I will proceed with side B1. And after that, working on side B2. So I will use what should I use? Oh, alpha. So sine alpha over A equals to sine beta 1 over B1. What is my alpha again? 27.5 sine 27.5 degrees over sine A 28.1 equals to sine beta 1, which is 92 on 31593. 31593. Let me make sure I don't copy that wrong. Okay, over side B1. So V1 equals to 28.1 sine 92.31593 degrees over sine 27.5 degrees, which according to our computation 28.1 sine 92.31593 divided by sine 27.5. I get 60 point something. 60.80592. So my B1 now is 60.8059. For B2, we will basically proceed the same way. Sine alpha over A equals to sine beta 2 over B. Sine 27.5 over 28.1 equals to sine, what's that? 32 point something, 32.68407, 68407 degrees over the 2. So fast forward, I get B2 equals to I get 32 point. I get 32.86242. 32.8624. Okay, that's for this section. That's for this section. Suggested homework will be number 1 from 7.1, number 1 to number maybe up to number 17 or number 19, up to number 19. Yeah. You will see the word problems later on basically boils down to the triangle. So you redraw the, you need to draw the the problems in the word problems, and then you boil that down to triangles with 6 components, okay, 3 angles and 3 sides. Okay, that's for 7.1. 7.2, the law of cosine. The law of cosine says the following. Suppose this is my triangle. Any random triangle, okay, it doesn't have to be a right triangle, even though it seems like this is a right triangle, but it's not. So let's say this is angle A, angle B, angle C, okay, and therefore this is side A, side B, side C. Suppose we are given side B and C and angle A. Then we will use law of cosine to find side A. Okay, notice that the angle here, the angle that we are given has to be the included angle. Okay, the included angle. What law of cosine says in this case? It says that side A squared equals to B squared plus C squared minus 2AB, sorry, 2BC or sine A. Okay, so notice that, and if we know side B and C and angle A, then we will know the opposite side of angle A. Okay, notice that I say that in I did say it this way. Notice that this side A here is opposite of angle A. See, right? Okay. Now, strangely, I hope that helps. That in the formula, side A also opposite of angle A. Okay. Okay, so for you to know side A, you need to know angle A. For you to know angle A, you need to know side A. Okay, now here's the proof. The proof. There are actually, as side note, two significantly different methods to prove this. Okay, and let me show you both of them. Let me show you both of them. The first one is something as the following. I like the proof. I would like to show you both of these proofs because both of them actually quite significant in enriching your view of triangle and trigonometry in general, of course. Okay, let's say this is angle A, angle B, angle C, and we know side B, side C. We want to know side A. Okay, so these are given. These are given. The first method is especially useful when we have angle A is acute angle, but it actually, you will see, it doesn't have to. Okay, my plan will be as the following. My plan will be, I will be able to find this H here. If I know angle A and side C, I will be able to find H. I will also be able to find this length here. Let's call this X. Now, using that X, then I will be able to find this value here, right? This is B minus X. Okay, and then I apply Pythagorean theorem again to find side A. Okay, that's the plan. That's for method one. That's for method one. Method. Even proving, there are two different ways, huh? Strange. Method one, I will first find H. So what is H? we know that sine A equals to h over c such that h equals to c sine A. Okay, let me keep it there. Second, cosine A equals to x over c such that my x is c cosine A. Step 3, d minus x therefore equals to d minus c cosine A. Lastly, we will be able to find A, where A squared equals to h squared plus b minus x being squared. Right? Now my h squared is c sine A being squared, and my b minus x is b minus c cosine A being squared. Now when I go on, this is c squared sine squared A plus b squared minus 2bc cosine A plus c squared cosine squared A. Then I will combine this guy with this guy. Okay, let me go down a bit further. Then I will get a squared plus b squared plus c squared parentheses sine squared A plus cosine squared A minus 2bc cosine A. But sine squared A plus cosine squared A is just 1. So I get now law of cosine. C, I'm missing a C there. Okay, that's therefore the proof of law of cosine. That's method 1. That's method 1. Notice that if cosine A is 90 degrees, if the included angle is 90 degrees, then we get Pythagorean theorem. Note, if A is a right angle, then cosine A is equal to 0. Consequently, we get A squared equals to B squared plus C squared. Right? So you can say law of cosine basically, law of cosine is basically Pythagorean theorem with some variation. Okay, Pythagorean theorem with some variation. This is the general form of Pythagorean theorem, but Pythagoras didn't invent this. It's somebody else. Somebody else actually found it. That's why it doesn't bear his name. Well, anyway, doesn't matter about who bears the name. The second method to prove that is actually something of my favorite, method 2. Now, it is by imposing this triangle into a rectangular coordinate system. So suppose I have one side of a triangle. I put it right on the positive x-axis. Okay. Let's say the length here is c. So the coordinate here will be c, 0. And then another side is, let's say here, it doesn't have to be obtuse though, but I'm just making it obtuse. Okay, let's say this is angle alpha. This is vertex A. Okay, and so this is angle alpha. And the length here is B. Now, according to what we learned in unit circle, this will be the coordinate of this point here, which is coordinate C. The coordinate C here will be, B cosine alpha, B sine alpha. Where's that from, Thomas? From here. Something we learned long time ago. Long time ago. This one. If I have a unit circle, and then I say that if I have any point on the unit circle, and the angle is in standard position theta, then the coordinate here, if this is unit circle, let's say unit circle, of course, is radius 1, then the coordinate here will be cosine theta, sine theta, right? Now, imagine if I change the radius instead of 1, I call that d. If the radius is b. So I basically extend it by b. Okay? Now, that's what happened here. If you have angle in standard position, angle alpha, and the distance from the origin is b, then that coordinate c must be given by these components. Now, side A that we have been looking for is actually the distance formula applied to these two coordinates. Okay, let's call this side A. Now that A squared equals to the distance formula. Okay, I apply that to difference of x components first. B cosine alpha minus c squared plus the difference of the y components, d sine alpha minus 0 squared. Okay, now the proof of method 2 here is very, very similar to the proof given by our textbook. But our textbook didn't invoke what we learned here. You know, I try to invoke that so that you remember. That's actually quite useful. Okay, now then, from here I go on. So a squared equals to d squared cosine squared alpha minus bc 2bc cosine alpha plus c squared. I FOIL that. I FOIL this guy, comes this. Okay, on the other hand, b sine alpha minus 0, just b sine alpha. Okay, so then I go on plus b squared sine squared alpha. And then you see that this guy plus this guy together will give us b squared. plus c squared minus 2bc cosine alpha. Okay, so this is, I think this is the first time in my class I provide you two different proofs of one formula. Okay, with this say that I want you to realize that to prove formulas is not unique. Okay, to prove a formula is not unique. I myself, by the way, I myself know three different proofs for Pythagorean theorem. I know three different proofs for Pythagorean theorem. And when I say three different proofs, it's significantly different proof. They are not just like similar to the other. No, no, no. It's totally different approaches. And somebody have ever wrote a book, as I remember, somebody wrote a book for 64 different proofs for Pythagorean theorem. Now, I don't think I will work that hard for proof for Pythagorean theorem though, but it's something quite interesting to see. Okay, well, anyway, the main purpose of this is not really on the proof. I show you the proof even though I will never ask you to prove. However, once you go to calculus, I know some instructors, they are actually big fans of proving. Okay, so in this course, even though I don't really require you to prove, I hope by me showing you how to prove, it actually equip you a bit more to proving when you go to calculus level. Okay, now let's do examples. Example 1. Suppose we are given the following. Suppose I have side A equals to 5, side B equals to, let's say, 7, and angle gamma equals to 75 degrees. I need to find side C. Okay. Now, of course, later on, we will solve this triangle. We will need to find angle alpha and angle beta. Okay. But see, I don't have a pair here. Notice that I don't have a pair. I don't have this pair. No. I don't have this pair. No. I don't have this pair. So I cannot use law of sine. Right? Okay. I cannot use law of sine. For me to use law of sine, I need to find this side C first. Okay, I will need to find that side C first. Now, let's work on that. Side C will be C squared here. Notice that if you have C squared here, then on the opposite side of the equals equation, you must have cosine of that corresponding angles, opposite of side C, in this case, cosine alpha. Okay, so not only in the triangle that they are opposites, in the equation also they are opposites. Okay, let's say this is A here and this is B. So A squared plus B squared minus 2AB cosine alpha. So C squared equals to 5 squared plus 7 squared minus 2 times 5 times 7 cosine 75 degrees. I will use my calculator. 25 plus 49 minus 70 cosine 75 degrees. I get C squared equals to 55.88267. So C, I apply the square root. I get 7.4757. Okay, now suppose from here I want to proceed finding angle alpha. I want to proceed finding angle alpha. Notice that angle alpha should be less than 75 degrees. Is it right? Yeah, angle alpha should be less than 75 degrees because yeah, side C is longer than side A. Okay, I hope that helps. I hope that helps. So when I use law of sine to do that, I'm sorry, not B, alpha. So when I use law of sine alpha over A equals to sine gamma over C. Then we have sine alpha over 5 equals to sine, what's my gamma again? 75 degrees over C, which is 7.47547. So sine alpha will be 5 times sine 75 degrees over 7.47547. I get sine alpha equals to 0.64606. So alpha 1 is sine inverse of that number. That's 40.24547 degrees. And because that's a sine is positive in 2 quadrants, then I will look for the angle in quadrant 2 also. Okay, even though I know I will cancel it later. That will be 139.7545 degrees, but I will cancel it. No, it's not applied. The reason is because alpha should be less than gamma. Maybe I say that because A is less than C, consequently, angle alpha should be less than angle gamma. Okay, that's why I cancel that. So I have, this is 40 point, let me use blue color. For step 2, this is 40.24547. Okay, likewise for angle B later on, you know that your angle B will be less than 75 degrees, slightly less than 75 degrees because it's slightly less than C, okay? But will be more than 40 degrees because side A is less than 7, right? So the angle should be, angle A will be less than angle beta. Is it okay? Now, that's something you can do later on your own. I hope you can do it on your own. But I want to offer you another way to find this angle beta here, angle alpha here. Another way to do it is by applying law of cosine. Notice that we have 3 sides already. At this point, we have 3 sides. We have side A and side B, side C. Now, if I have 3 sides, then I can use these 3 sides to find whichever angle I need. Okay, now suppose I want to find angle alpha. If I want to find angle alpha, then what I need to do is to put a squared here so that I can get cosine alpha there. Okay, remember the opposite sides, right? Okay, so this is b squared plus c squared minus 2bc cosine alpha. Now my a is 5 squared. Is it 5? Yeah, is it 5? My b is 7. My c squared, I take it from here. Let me use this. My c squared, I take it from here. And my c, I happen to have both of them already. C, I put it there. Okay, my c squared is 55.88267 minus 2 times 7 times 7.47547 cosine alpha. Now, if you use law of cosine, you will see if you use law of cosine, it's longer, but you have only one angle for that. Okay, you will have only one angle for that. Let's see, this is 25 equals to 49 plus 55.88267 minus 14 times 7.47547 cosine alpha. 49 plus 55.88267 times 7.4757. Oh, by the way, you cannot combine these two. You cannot combine this term with this term because they are not like terms. Okay, so please don't do that. What I can do, however, is let me do it this way. Let me subtract by 104.88267. I get negative 79.88267. And then I will divide by that 104 something. So cosine alpha will be 79.88267 over 104.65658. What is that? That's 0.76328. So alpha 1 is cosine inverse of that. I get 40.24545 degrees. You see, I have a little bit off, but that's because of the rounding error. Okay, either one is okay. Now, the thing is, why I say cosine using law of cosine is better, even though it's longer, is because it gives you only one angles. Cosine is positive in quadrant 1 and quadrant 4. So even if you get the other angle here, it must be in quadrant 4. which is greater than 180 degrees. That's why you cancel it out, right? Under no situation, you get angle in more than 180 degrees, right? Okay, so law of cosine, even though it's longer, it gives you only one solution. Even if the cosine here, cosine alpha here, give you a negative number, it will give you quadrant 2 or quadrant 3, which is more than 180. So you will have only one possible solution. Okay, sine, law of sine will give you two solutions here. With some wisdom, then you may be able, and you should be able to cancel one of them. Okay, so which one you recommend, Thomas? Well, depends on how much you know even before you start that procedure. Okay, what makes me, if I were the one doing this problem, I will use law of sine because I can tell right away that angle alpha should be less than 75 degrees, right? Angle alpha will be less than 75 degrees. When I work it out, I still need to write this though. And then I cancel it. Okay, simply because when I solve for sine alpha equals to that, I should have two solutions. Okay, so likewise, actually, when I do this, I should have two solutions, even though I will for sure cancel the ones in quadrant 4. Okay, now here, there are two solutions for sine alpha equals to 0.6 something. There are two solutions for that. Okay, and both of them less than 180 degrees though. So we need another reason to cancel alpha 2 in this case. I have seen a case in the past where I cancel alpha 1. I have seen a case in the past that I cancel alpha 1. So please be careful with which one you cancel. In the examples I gave you here, apparently I always cancel alpha 2, the one in the second quadrant, right? But that's not always the truth, okay? You need to observe what we have up here. Now, the reason I went over law of the second method here using law of cosine is actually to also teach you how to find the angles if we know three sides of a triangle. So let's say, for example, another example, suppose I have three sides of a triangle like let's say I use number 18. It is given that side A is 20.0. Let me just say 20. Side B is also 20. And side C is 10. Now then, I need to find angle alpha, angle beta, and angle gamma, knowing three sides. Okay? Now then, you decide, up to you, which one you want to do first. You want to find angle alpha first, or beta first, or gamma first. It's up to you, either one. One thing we know is the following. Angle alpha will be equal to angle beta in this case. It just happened, because two sides here are the same, right? Because if you have two congruent sides, then the opposite angles must be congruent as well. Okay, that's something we learned from geometry though. So let me find angle alpha. Okay, let me find angle alpha, because basically if I can find angle alpha, angle beta actually comes for free, which is not always the case. Okay, but in this case it's doable. Okay, so if I want to find angle alpha, cosine alpha here, then my opposite side should be A, right? A squared equals to B squared plus C squared minus 2BC cosine alpha. So 400 equals to 400 plus 100 minus 400 cosine alpha. Let me cancel the 400. Okay, let me cancel the 4. Happens to be a nice numbers here. So I get 0 equals to 100 minus 400 cosine alpha. So cosine alpha is 1/4, right? 100 over 400. So which is 0.25. So alpha will be cosine inverse of 0.25. That is 75.52249 degrees. Okay. Now then, how about angle beta? You can apply law of cosine again if you want to. Okay, but I would just use the common knowledge. Since side A equals to side B, then angle A equals to angle beta. Angle alpha equals to angle beta, which is 75.52249 degrees. Then angle gamma consequently comes together with that, right? So alpha plus beta plus gamma is 180 degrees. You can use that. This is 151.04498 degrees plus alpha plus gamma equals to 180 degrees. So gamma will be 28.95502. Okay, so I'm basically done with the law of cosine. But we have more questions to do. How about the area of a triangle? We never really work on a question like that. Area of a triangle. If known, two sides and included angle. Notice that uh, this is the same configuration, to law of cosine, at which you have two sides and included angle. So you know side angle A, side B, and side C. If these are known, then area of the triangle equals to 1/2 the product of two sides sine of the included angle. Okay, see what I did in 7.1. So suppose for example I have number 38. Angle gamma is 45 degrees. Side B is 10. And then side A is 15. So the area of the triangle is 1/2 AB sine 45 degrees. That is 75 times radical 2 plus 2. That's 37.5 square root of 2. That's the exact solution there. Okay, if you want to make it into decimals, then you use your calculator further. Okay. Oh, by the way, then actually at this point, I can ask you this question. One of my favorite question. Consider a stop sign with radius, let's say 8 inches. A stop sign has 8 sides. I hope you realize that though. If you drive, you're supposed to know this, right? Okay, now when we say the radius is 8 inches, it refers to the distance from the center to the vertex. Okay, the radius. This basically means that this stop sign can be inscribed in a circle with radius 8. Now, there are two possible questions from here. The first question, find the perimeter. Find the perimeter of this stop sign. Then the perimeter equals to, I will deal with on this one side here, this one triangle here. Okay, I will deal with this one triangle. Now then, the perimeter, because a stop sign have 8 sides, the perimeter, let's call this S here, is 8 times that S sides. Because again, it has 8 sides. Let me change that 8 inches becomes, let me change it to 10 inches instead, so that you don't confuse that with these 8 sides. A stop sign have 8 sides. We call that octagon. Okay, now then how do we find the sides? Side squared equals to, notice that in this triangle, each side is, in this triangle, you have 10 here, 10 here. What is the included angle? Call that angle theta. Angle theta is 360 degrees divided by 8 such triangles. That give us 45 degrees. So by law of cosine, we will get, this is 10 squared plus 10 squared minus 2 times 10 times 10 cosine included angle 45 degrees. This is 200 minus 100 square root of 2. So S will be the square root of that. That will be 10 square root of 2 minus square root of okay. I kind of Russian. It's basically square root of this, right? Square root of 200 minus 100 square root of 2. But I can factor the square root of 100. That's square root of 100 times 2 minus square root of 2. Now, the square root of 100 comes out, becomes 10 square root of 2 minus. Okay, so the perimeter therefore equals to, the perimeter therefore equals to 8 times 10 square root of 2 minus square root of 2. You can just use your calculator if possible, if you want to. But the way I see, because 45 degrees is a special angle, then we're supposed to answer it using It's a special angle, so we need to use exact form. Okay. If then you want to make it in decimal, you can go on from there. The second possible question is, how about the area? How about the area of that stop sign? The area of that stop sign equals to 8 times the area of such triangle, which is 8 times 1/2. The product of two sides, both of them are the radii, sine 45 degrees. Okay, now this 45 degrees comes from here. Okay. And the radius are 10, I believe. So this is 4 times 10 times 10 radical 2 of 4. That's 200 radical 2. That's the area of stop sign. Now, in the past, I asked, for example, hexagon, which is 6 sides, or decagon, which is 10 sides. Now, I possibly ask nonagon, which is 9 sides, or pentagon, which is 5 sides. Basically, if I have regular pentagon, then with the given radius, then you should be able to find the perimeter and the area of those polygon. Okay. Now, last one, which I will not prove, also to find the area of a triangle. Area of a triangle with 3 sides known. Yes, on the test, I may ask you that area of and perimeter of a polygon, a regular polygon. Yeah, somebody asked me that question. Will I ask that area and perimeter? Yes, in terms of polygon. Actually, for every triangle, of course, I can ask you now what's the area and what's the perimeter. But the perimeter of a triangle is basically just the sum of all 3 sides. Okay, so for triangle, that's actually obvious. The one that we have not known yet is the perimeter of the regular polygon. Okay. Now, the area of a triangle with 3 sides known, we will use what we have learned in geometry. We will use Heron's formula. We'll use Heron's formula, that is the area of the triangle equals to square root of, I will not prove it, but the proof is in the book. S times S minus A times S minus B times S minus C, where S is semi-perimeter. It's half of the perimeter, half of A plus B plus C. Okay, as I know you already learned this in your geometry class, which is the prerequisite for this class. But let's do one example as the closing. Suppose, for example, I have a triangle with side A equals to, let's say, 10, side B is 12, and side C is 16. I make up numbers. So how to find the area. Solution. Find the semi-perimeter first. Semi-perimeter, which is 1/2 times the perimeter. 1/2 times 10 plus 12 plus 16. 38 divided by 2 is 19. It's 19. So the area of a triangle, that triangle will be the square root of the product of semiperimeter times semiperimeter minus A, semiperimeter minus B, semiperimeter minus C. The square root of 19 times 9 times 7 times 3. Okay, now I will use my calculator. 19 times 9 times 7 times 3. That will be square root of 3,591, which is 59.92495. Okay, that's the area of that triangle. The suggested homework from here will be 7.2 number 5 to number 21, and then number 37 to number 43. Just do the odd ones. Okay. Now I would like to give you extra homework, suggested homework. I want you to watch Math 260, my Precalculus at West LA College. Watch their 13.4, I'm sorry, 13.3, their 13.3, 13.4, 13.5. If possible, also 13.2. Maybe you watch 13.2 first. Well, anyway, 3 of them, if you have a chance. Okay, at least 13.3 then. Yeah. What I will do on Monday, I will do 13.2 first. I will do 13.2 first and then 13.3. Okay, yeah. If possible, you have 4 days, 4 or 5 days for that. Okay, that's for today.